Q8301. The exhaust gas temperature, EGT, indicator on a gas turbine engine provides a relative indication of the A. Exhaust temperature. B. Temperature of the exhaust gases as they pass the exhaust cone. C. Turbine inlet temperature. The correct answer is C. The exhaust gas temperature, EGT, indicator on a gas turbine engine provides a relative indication of the turbine inlet temperature. The EGT sensor is typically located in the exhaust gas stream after the combustion process has taken place and before the gases enter the turbine section of the engine. By measuring the temperature of the exhaust gases at this point, it provides an indication of the temperature of the gases entering the turbine, which is closely related to the turbine inlet temperature. Monitoring the turbine inlet temperature is crucial for the safe operation and performance of the engine, as it helps prevent overheating and potential damage to the turbine components. Q8302. What instrument indicates the thrust of a gas turbine engine? A. Exhaust gas temperature indicator. B. Turbine inlet temperature indicator. C. Engine pressure ratio indicator. The correct answer is C. The engine pressure ratio, EPR, indicator is the instrument that indicates the thrust of a gas turbine engine. The EPR is the ratio of the total pressure at the engine inlet to the total pressure at the engine exhaust. It is a measure of the engine's overall pressure rise and is directly related to the amount of thrust the engine produces. The EPR indicator provides a relative indication of the engine's thrust level, allowing the pilot or operator to monitor and control the engine's performance. By observing the EPR readings, adjustments can be made to optimize the engine's thrust output during different flight conditions or power requirements. Q8303. In a turbine engine, where is the turbine discharge pressure indicator sensor located? A. At the aft end of the compressor section. B. At a location in the exhaust cone that is determined to be subjected to the highest pressures. C. Immediately aft of the last turbine stage. The correct answer is C. The turbine discharge pressure indicator sensor in a turbine engine is typically located immediately aft of the last turbine stage. This location allows for the measurement of the pressure at the point where the exhaust gases exit the turbine section and enter the exhaust cone or nozzle. By placing the sensor in this position, it provides an accurate indication of the pressure in the turbine discharge and allows for monitoring and control of the engine's performance. The turbine discharge pressure is an important parameter to measure as it provides valuable information about the engine's efficiency and the overall performance of the turbine section. Q8304. In what units are turbine engine tachometers calibrated? A. Percentage of engine RPM. B. Actual engine RPM. C. Percent of engine pressure ratio. The correct answer is A. Turbine engine tachometers, also known as engine speed indicators or N1 indicators, are calibrated in percentage of engine RPM, revolutions per minute. The tachometer provides a relative indication of the engine's rotational speed, typically referring to the rotational speed of the engine's low-pressure compressor or fan section, depending on the specific engine configuration. The tachometer scale is calibrated from 0% to 100%, with 100% indicating the maximum rotational speed or maximum power output of the engine. By monitoring the tachometer, pilots and operators can ensure that the engine is operating within the desired speed range and make appropriate adjustments as necessary for safe and efficient engine performance. Q8305. Instruments that provide readings of low or negative pressure, such as manifold pressure gauges, are usually what type? A. Vane with calibrated spring. B. Borden tube. C. Diaphragm or bellows. The correct answer is C. Instruments that provide readings of low or negative pressure, such as manifold pressure gauges, are typically of the diaphragm or bellows type. Diaphragm or bellows pressure gauges utilize a flexible diaphragm or bellows that expands or contracts in response to changes in pressure. As the pressure changes, the diaphragm or bellows moves, and this movement is then transmitted to a mechanical linkage or indicator needle, which provides the pressure reading on the gauge face. These types of gauges are well suited for measuring low or negative pressures because the flexible diaphragm or bellows can respond to small pressure differentials accurately. Board and tube pressure gauges, option B, are more commonly used for measuring higher pressures and are not typically used for low or negative pressure readings. Vane with calibrated spring, option A, is not a common type of gauge used for pressure measurement.